That's the button. There we go. Oh wait, how does the virtual camera work for OBS?
I'm not even using virtual camera.
Oh
I'm
yeah, I
just
know, but
using
I'm wondering if that would have less issues.
oh, maybe. I can try that.
Hmm. I mean, this right now it's working, but yeah, if we have issues again, you know.
Yeah, I'm gonna try and figure out what causes it. But yeah, maybe I'll try virtual camera instead of trying to share the preview window.
Yeah, maybe that'll work.
Anyway, link is in general, as always. Question is there. Good luck.
Nice Spanish zoom.
What?
I like the Spanish zooms. Potato my
Okay, is that everyone? I think so, right?
Yes, it is.
All right. So it's the velocity of the car just before impact and the duration of the collision. That is because of the formula right to the left of the question. F is equal to change in momentum over change in time. So you need the duration of the collision and you need the momentum, which means you need the velocity. Yep. Any questions about that one?
uh may I ask you to briefly um repeat that? I was AFK. Sorry.
Okay. So it's C because of the two equations to the left of the question. In order to get the average force exerted by the wall in the car, which is F, you need change in momentum over change in time, so you need the duration of the collision. And then for momentum, you need velocity. So you need the velocity of the car, and you need the duration of the collision.
Okay.
Any questions? All right, cool. Okay, just a couple more minutes here.
All right, that's 4.
All right. Okay, so it is 112 newtons.
Ooh,
So let's
okay.
go over that. Okay, so first of all, if I can find anywhere on this board that's actually blank. All right, here. I need to clear this board out soon. All right, so it says a 22-gram puck. We already know that we're going to need to change those units to not be grams, change it to kilograms. So what is 22 grams in kilograms?
22 kilograms.
Yeah. Oops. Okay. So then it says it initially has a speed of 14 meters per second. So its momentum initial is equal to uh, 0.022 its mass times its velocity, which was 14. So its initial momentum is 0.308. Okay. And then it said that its final velocity was 14 meters per second in the opposite direction. So um, its final momentum is going to be its mass of 0.022 times negative 14, or 14 meters per second in the opposite direction, which is negative 0.0, wait, no, 0.308. Okay, so what is the change in momentum from the initial to final?
Um, 0.616 or negative 0.0 or 0.616.
Yep. So remember that change is always final minus initial, so change in momentum is equal to negative 0.616. And then finally, the question asked us for the average force, and remember that force is equal to change in momentum over change in time. We know that the change in momentum was negative 0.616. We know that the change in time from the question was 0.0055. And if you do that out, you get 112, specifically negative 112, but all of the answers are just magnitude. As it says the question, what is the magnitude of the average force? So all the answers are going to be positive.
How do you know when to use momentum and when not to use it? Is it just for collisions?
Pretty much, yeah. Momentum will usually be used around collisions. That's pretty much the only way to figure it out. A lot of collision problems and momentum problems in general, you can actually solve without momentum. You can solve it just with traditional force and um, kinematics and that sort of thing, but it will take like 3 times longer. So you're better off identifying that it's a collision and trying to use momentum.
Yeah, because I mean, if you identify it's a collision, these solves gonna be momentum, and you can't use energy because energy is not conserved in all collisions. It's conserved if it's elastic, but at that point, it's almost more work to use energy just because there's more numbers to put in and you have to square it and do half instead of just doing number times number. So, you know.
All right. So let me add some more questions. All right, looks like everyone. Okay, so momentum is conserved during the collision, but is not conserved during the motion before and after the collision. So can anyone remind me what has to be true for momentum to be conserved?
Mass stay the same, velocity stay the same.
Not necessarily. So momentum is always conserved when there is no external forces acting on the system. That is the only requirement. So we know that, during a collision, a typical collision, unless it says otherwise, that there are no external forces acting on the system. So since it just says the what does it say? Where does it say that? It just says that they collide. And you could also work it out by saying multiplying the mass. I don't know if it gives you the mass. No, it just says equal mass. So basically, you just have to infer that since it doesn't say anything specific happens during the collision, that during the collision momentum is conserved. However, at the very beginning, it says that an object is sliding at 12 meters per second, and then when it comes to the collision, it's slowed down to 10 meters per second. So it tells you it slowed down, which is implying that some other force, likely friction, acted on that object.
Yep,
So
it says it's on a
during
rough
that,
table too. And typically, if they're gonna say anything about rough, you're That's how they're probably going to tell you if it's friction on the test, is if it says smooth or rough surface. Because if it says a smooth surface, there's no friction. If it says a rough surface, there's friction. And that's going to be true for pretty much every single question on the AP test.
So it says, it slowed down. It was on the rough table, so that tells you that a force was acting during the beginning. So its momentum is not conserved before the collision. And then after the collision, it was 5 meters per second, and then it slides to a stop. So again, after the collision, it slowed down. So there had to be an external force of friction, and so momentum was not conserved after the collision. Any questions?
Wasn't there friction before though as well?
Yep, that's why it says momentum is conserved during the collision, but it is not conserved during the motion before and after the collision.
Oh, okay.
Okay.
All right, that's 4.
Okay. So good, most of us got it right. Momentum is conserved and kinetic energy is not conserved.
The way you can know
And
that
that's
is because it says inelastic collision, not elastic collision. If it was an elastic collision, A would be right. But in an inelastic or completely inelastic collision, you will have energy will not be conserved.
Yep. Are there any questions about the difference between an elastic collision and an inelastic collision?
What happens in an elastic collision? Can you explain that?
You said in an inelastic collision?
Yeah, an inelastic.
So, in an inelastic collision, they have to either give you the velocities and the masses of the objects at the end. So that's essentially giving you the kinetic energy that's present at the end, and then you can figure out the change in kinetic energy. And then you can combine the change in kinetic energy with the um, momentum equations to solve for whatever they're asking you for. Or they could do the more likely option and tell you it's completely inelastic or perfectly inelastic. Both of those mean the same thing. And in a perfectly inelastic collision, the two objects stick together. So it's essentially like if you have, turn that off.
Also, this completely inelastic collision is the most possible energy loss.
Yep. Um, yeah. So it's essentially the most energy that can be lost during collision while still conserving momentum. But it's basically if this object was going large speed and this object was going small speed, after they collide, or maybe they could be stopping, or it could have stopped, it wasn't moving, or it could have been going the other direction, whatever. The point is, after the collision, the two objects are stuck together and they're moving with some velocity at the same speed. And so in a perfectly inelastic collision, the key that you know is that after the collision, the velocity of the first object final is equal to the velocity of the second object final.
Okay. Thank you.
Yep. And then in an elastic collision, the other condition is just that change in kinetic energy is 0 for the whole system. So all right, any other questions? Okay.
All right, that's 4. So we just talked about this. If they collide and stick together, then that's completely inelastic. It's the furthest away from elastic it can be. And only elastic collisions have no change to kinetic energy.
Was my mic off the whole time?
For just the last little bit, yes.
Okay, cool. So yeah, so Alan was saying a little bit there. Does anyone who got 161 want to explain how they got it? No. Okay. So let's move out over here. Okay. So mass A of 2 kilograms moving at a velocity of 15 meters per second. So the initial momentum, or the momentum of object 1, or object A, sorry, initial, is 2 times 15, and that's 30. And then the momentum of object B, initial, is equal to 0 because it's initially at rest. So the momentum, let me turn that off. The momentum of the system initial is equal to 30. And then it says, after the collision, the two objects stick together and move as one. So the momentum of, the final momentum of object A is going to be its mass, which was 2, I believe. Yep. Two times whatever the velocity of both objects is, and likewise the momentum of object B final is going to be 5 times whatever the velocity of both of them is, so that the final momentum is equal to 2v plus 5v, which is the same as v2 plus 5. And remember, momentum is always conserved. Even though it's an inelastic collision, that's just to do with energy. Momentum is still conserved here. So since the initial momentum was 30, we now need to go over here and find final momentum. So we know that the final momentum is still equal to 30. So we now have 30 is equal to v2 plus 5, and that's just 7. So we divide both sides by 7. And so the velocity of both objects afterwards is 4.29 meters per second. And so then finally we have to find the change in kinetic energy. So can anyone tell me how we would get the initial kinetic energy?
One half mv squared.
Yep. So 1/2, and the only object that's moving at the beginning is mass A, so that's just going to be 2 times v squared, which is 15. And that comes out to 225. And that's the initial kinetic energy. And so the kinetic energy final then is going to be 1/2 the mass A times our velocity squared, which is 4.29 squared, plus 1/2 times the second mass, which was 5, times the velocity squared, 4.29 squared, And when you do that out, you get I don't think my calculator is doing order of operations. But anyway, so point is you would solve this part here for the final kinetic energy. And then you just take 225 up here minus whatever answer you get for this, and that's going to give you your change in kinetic energy. And that will be the answer. Are there any questions? So when you do that, I just worked it out. So the kinetic energy final, real quick, is 64.414. And then you do final minus initial, and that gives you negative 160.58. And then the question said, what is the change? And it says decrease by 161. All right. If there's no other questions, we'll move on.
What's a ballistic trajectory?
It doesn't necessarily matter for this problem, but it just means a parabola, pretty much.
Okay.
All right, let's take a look. Okay. So, this is something we haven't talked about a whole lot, but you are going to have to know, pretty much. So, imagine, here, let me move over. So we have, remember they're on a frictionless surface, and we have this person. And he has some mass, and his velocity is 0. And then, some time passes, and we have this person, and he's thrown a ball. And so then he has some mass, and the ball has some mass, and the velocity over here is positive. And remember that momentum is conserved. So momentum over here was some number, and momentum over here, well, actually, momentum over here was 0. And momentum over here has to be 0. But the ball has non-zero momentum because it has some mass and it has some. Oh, sorry, it's behind the thing. And it has the ball has some momentum because it has some mass and it has some velocity. The person has the same mass, but in order for the total momentum to be 0, this person has to have a negative momentum. So he has to now have a negative velocity. And in order for him to have started moving backwards, there had to have been a force from him throwing the ball backwards on him. So that's why it says that the answer is he feels a backwards force exerted by the snowball he is throwing. And again, just sort of think about it. If you imagine you're on a frictionless surface like ice, and you have like a boulder, and you throw the boulder, you're going to go backwards after you throw the boulder. The boulder will go forwards, but you will start moving backwards a little bit. Okay. Are there any questions about this one? Okay. So that's all the questions that I have up on item pool. However, there's one more from this question, or similar to this question, that I want to go over because it might be on the test as well. So imagine we have a firework, and the firework has a mass of 2 kilograms. I know, very aerodynamic firework there. Hello, who is this? Hello, okay. So imagine that the firework has a mass of 2 kilograms, and then we shoot this firework straight up. And then at the highest point in its trajectory, right before it starts falling, the firework explodes, and it shoots 0.5 kilograms of its mass in the left direction with a velocity of 2 meters per second. And the rest of the mass goes to the right. So how can we find the mass that goes to the right and the velocity of the mass that goes to the right? So let's start off with the easy one. How can we find the amount of mass that goes to the right?
Wait, you can find both mass and
If I said that, yeah, because I said all of the rest of the mass goes to the right.
so saying that all of the 2 kilograms
Minus 0.5, yeah.
minus the 0.5. Okay, yeah. Okay,
Thank you for saying the answer, but it's fine.
I said minus the 5. Look, if they can't subtract a number from a number at this point, we have a problem.
So yeah, so the firework up here is, as Alan so eloquently said, is 2 kilograms because we said it was. And then after it explodes, 0.5 of the kilograms go to the left, and I said that the rest of the mass goes to the right. So 1.5 kilograms
Well,
goes to the right.
because the reason is that typically an explosion is triggered by something, and therefore the mass of the explosive is consumed. That's why I was confused, because well, if the mass changes, then you can't find both. But that makes sense.
I don't even. I mean, unless they gave you both masses, this is how they would do it, and I'm pretty sure they did it on our test.
Yeah.
Anyway, so 1.5 kilograms goes to the right. The second question was, how can we find the velocity of the mass that goes to the right? So does anyone have any ideas as to how we would do that?
So find the kinetic energy of the piece on the left, and then it has to be equal to the one on the right, right? So then 1 joule equals mv squared. We know m is 1.5, and then v squared, and then do all the math stuff, and then you get 2/3, I think.
So why would the kinetic energy be equal on both sides?
I don't know.
It's not, is the answer. When it explodes, there's kinetic energy increases because if you think about an explosion, right, it's nothing's moving, and then it explodes, and then things are moving. Kinetic energy just increased. So this is, if you think about it in terms of a collision, this is an inelastic collision. Even though it's not technically a collision, I'm aware, but we still refer to this as a type of collision. So the kinetic energy is not conserved in this problem. what is conserved in this problem? Let me say.
Momentum?
Yes, momentum is conserved. So what is the momentum before it explodes? And we said that it's a 2 kilogram firework explodes at the highest point after we throw it up. So what is the momentum right before it explodes, in the instant before it explodes?
0.
Yes. So the initial momentum is equal to 0. So then, what is the momentum of the mass that goes to the left?
1.
Yep, because it's going to be 0.5 kilograms times the speed or the velocity, and that's going to be 1. So what does the momentum of the left side have to be, since we know that the final momentum has to be 0 of the system?
-1.
Yep. So the final momentum of the right side has to be -1. And so how can we then solve for the velocity of the right side?
Algebraically, -1 equals 1.5 times v.
Yep. And then that's just v.
Why is it -1 though on the right side? Because of the opposite direction.
Yep,
Because the left is 1.
that's one of the reasons, is just opposite direction. But the other one is we said that the initial momentum of the system was 0. So the final momentum of the system has to be 0. And we already said that the left side had a momentum of 1. So you have to add some momentum to 1 to get 0, and the only thing you can add to 1 to get 0 is -1. You could have defined this side as being -1, and then you would say this side is +1, and you'd get the same answer. It doesn't matter, but one of them has to be negative and one of them has to be positive.
Okay.
But yeah, you just do 1 over 1.5. And that's 2/3, so the velocity on the side is 2/3.
So I almost used the wrong formula and still got the right answer. Almost.
You know, sometimes it'd be like that.
Sometimes it does be like that. To be fair, if they had done something weird with the numbers, then it might not have. But I'm just telling you that if they gave this type of question, that may not always work. It happened to work for the numbers that I picked. That's not always true.
And AP, I feel like double checks that kind of stuff and probably won't have questions that you can answer the wrong way on their test. But, you know, maybe sometimes they forget to do those checks.
No, yours doesn't actually work. I just double checked it. You would get 1/3 if you did it with kinetic energy.
So wait, did you try to do something else, do it wrong, and get the right answer? Because if so, that's quite impressive.
Because, okay, just for the sake of pointing it out, right? So the kinetic energy of the left side is 1/2 times 0.5 times 1 squared, which is, I believe, just 1. Or hang on, 0.5 times 0.5, no, times 1, no, sorry, 0.25, 0.25, what am I doing? Maybe I did this wrong again. Anyway, so 0.25. Oh, never mind, this is 2, that's why it was 1. Sorry, this is 2, so it is 1. I was right the first time. So this is 2 squared. And so the momentum, or the kinetic energy to the left side is 1. And then if you did 1 is equal to 1/2 1.5 v squared, you end up with 1.5 times 0.5, 1 minus that. You end up with 0.25 is equal to v squared, and so ignore the random lines, and the square root of 0.25 is 0.5. So that's just, it doesn't work. So
So,
I don't know what you did in your head that you got it wrong, but you got it right. But
I
kinetic energy
mean,
doesn't work.
that's impressive.
Also, he left, I think, but it's fine.
Alright, well. Whatever.
Bye.
What time is it
Uh,
now? Is it 30?
26.
26.
All right. Well, before you go, We finally, praise the Lords, got Albert IO.
Yeah, we
It only-
did. Thank God.
it only
It should
took-
be
it-
something in your guys' Canvas page. You guys should have access to it.
We did our first Albert.io for English, and it was terrible.
Oh no, like
So
it's
annoying.
no. Well, I will tell you, it is pain, but the pain gets you the good test grade. Like, it is not fun by any means, but it is like the best way to prepare for the test by far.
It only took the school literally like 4-5 months to get this to us, but it's fine. It's cool.
No, we still don't have Spanish textbooks. I don't want to hear about Albert IO.
Albert
We
IO
watched
is better
some
than your
dumb
Spanish
video in
textbook.
Spanish.
I mean,
this
realistically, I don't really
dumb?
think you need textbooks for Spanish, but whatever.
You know, you don't.
Nathan, I have learned no Spanish, and I need to take Spanish 4 next year.
Wait,
No, you don't.
Uh,
Okay,
yeah,
don't.
I
Okay,
did.
don't pay attention to the numbers because the Spanish 4 that you're taking next year is just wait. Hold on. Yeah, no, the Spanish 4 you're taking is just your next Spanish class.
Yeah, but
Yes.
Alan, we
Sorry.
had to take 5 years of Spanish in 3 years, so I wouldn't be talking.
We didn't never had to take 5 years. It took-
We have to
No.
go Spanish 1 through 5 because ours is numbered 5, and we missed one
Okay.
year of Spanish.
Goddard Anderson explained this before. It's like
I am
it's
leaving.
Florida is dumb as hell, and they're like, well, we can't have the same numbers be for different classes, so therefore it's got to be 4 and 5, even though it doesn't have to be 4 and 5, and they're just being stupid.
Anyway, that's that. Everyone's already left for some reason, so
Yep.
adios.
Alright, see it.
Alright.
See, I was gonna ask, when we want to do the full tests, but then everyone just started leaving.
Yeah. Alright, let me stop recording.